Hi, and welcome to the second Railway Age and Railway Track and Structures Supplier Innovations virtual event. I'm Mary Beth Luzak, Executive Editor of Railway Age, and I'll be moderating today's sessions. We have an excellent lineup of speakers who will cover the latest technologies on the mechanical side of the business. I'd like to thank ThermOmegaTech and ZTR for their sponsorship and participation today. Before we begin, there are a few things to keep in mind. First, send your questions throughout the event using the Ask a Question field. Our speakers will answer questions at the end of each session as time allows. You can also use this field if you have any technical issues. You can change the volume using the tools below the video. And finally, you can download PDFs of the presentations in the event resources section. And now our first speaker is Glenn Quinty, Senior Design Engineer at ThermOmegaTech. With more than 30 years of experience, he works to develop innovative thermostatic solutions for the railroad, aerospace and defense, industrial, and commercial plumbing industries. Glenn oversees projects from start to finish, utilizing DFM and DFA techniques to design thermostatic, self-operating valves and devices. Glenn, thanks for joining us, and I'll turn it over to you.
We're going to talk about our self-powered type of valves that are used for freeze protection. So as you can see on our first slide here, it's how the Guru PC protects passenger train cars from freezing. So the need for freeze protection, as I'm sure everybody's aware, water freezes at 32 degrees Fahrenheit. And when it does, it tends to expand at about 10% by volume, which causes a lot of problems as far as like broken pipes and everything else. So without a proper freeze protection solution, passenger cars' potable water bearing systems are at risk of freezing. Typically when the car's heat is turned off or during a layover, locomotive switch, or power outage. The consequences of that, as I mentioned previously, are burst or cracked pipes, interrupted kitchen galley service or sanitation systems, and also the result of that will be costly and very lengthy repairs. The way we do this is, powerlessly I'll say, is through thermostatic technology. So since 1983, ThermOmegaTech has been protecting diesel locomotive cooling systems from freeze damage using thermal actuator technology. How the thermal actuator works, utilizing a thermaloid type material within our wax actuators, the diaphragm expands as the temperature increases above the material's melting point, pushing on a piston to open and close the valve, which would be the hot position. The piston then retracts as the thermaloid material cools, and the diaphragm returns to its cold position. Temperature ranges we typically cover from 15 F to up to 300 degrees Fahrenheit. And as you can see by the animated slide on the right there, it's going from cold, retracted, to in blue to red, extended. And what it's doing is that the thermaloid wax material is changing state from when it's blue, it's in its solid phase. When it transforms to its liquid phase at a higher temperature, it expands by about 14 to 18% by volume. And what we do is take advantage of that by having it stroke a piston out. And so by using some innovative design techniques, we incorporated that into this Guru PC valve, which I'll show you in a minute here. So the benefits of thermostatic valves, well, obviously the first main benefit is it's self-powered. Can be located virtually anywhere, in any position. No electric power required, ideal for winter storms and power outages. It's used as the main source or actually as a backup fail-safe for other powered devices that are either electric or whatever type. Virtually maintenance-free, very predictable, very simplistic design, as you saw from the little animated slide. And the actuator component has a high power-to-weight PTW ratio, which is a very coveted aspect for allowing a compact size while still providing optimum valve performance. So in other words, you're trying to get something smallest, the lightest, that can produce the most force. That's what the goal is with that. So the Guru PC passenger car freeze protection valve, it protects passenger train potable water bearing systems from freezing in the winter. The operation, it's self-operating. It is NSF 61 certified, so it's lead-free to be used for potable water. The valve constantly monitors the ambient temperature. Should the ambient temperature fall below the valve set point of 35 degrees F, 3 degrees above freezing for water, the valve will modulate open to drain the water out before freezing can occur. Once power and heat are restored by via the floor heat or whatever, the valve will modulate closed. We also offer an electric heater assembly, which is preferred. I'll explain why in a minute. It closes the valve within minutes of power to allow refilling of the potable water system after drain occurrence. And it's typically wired into the floor heat system. So what are the key pain points of the Guru PC with the heater that the heater assembly solves? It's ease of activation and reactivation. So there's no outside power sources needed for the valve to open and drain the water tanks. The valve will close again once it senses temperatures above its set point, up around 40, 42 degrees F or so. Automatically prevents potable water tanks from freezing, mitigating the risk of expensive and lengthy repairs and delaying schedules. Repeatability, it's not just a one-time use valve. It can be reset and used many times over a few years. When using the electric heater assembly, the operators can expect to have their systems filled and back in service within minutes. We have a little demo that we can pull up and show you now. It'll show you how the Guru PC reacts to the ambient temperatures, the water drain once set temperatures reach, and the heater assembly quickly closing the valve. So back to Mary Beth.
Hi everyone, thanks for tuning in to today's webinar on our passenger car freeze protection. I'm Dana Loeb, Railroad Product Manager here at ThermOmegaTech, a Loeb family holdings company. And with me today I have our Senior Design Engineer, Glenn Quinty, who is also today's presenter. So today we're going to be demoing our two valve sizes that we have. We have the 3/4 inch Guru PC over here, as well as our 1 inch Guru PC. The main difference between the two is just going to be the flow. The 1 inch Guru PC offers double the flow. So what we want to show you today is how our thermal actuator technology works. It senses the ambient temperature rather than the water temperature. So when the valve set point as 35 degrees Fahrenheit, when the ambient temperature gets to that set point, it's actually going to modulate the valve open to drain your potable water tanks before any freeze damage can occur. So we'd like to show you how that works today. Well, I'm going to go ahead and pour this in. Both of these here. So now we're going to show Glenn using a quick freeze spray to simulate ambient temperatures getting close to 32 degrees Fahrenheit. And what this is going to do is going to modulate the valve so that it's open and the potable water tanks will drain. So Glenn, if you want to go ahead and spray that actuator, and let's just show how the valve works without any power or any electricity. So here you can see within seconds, the valve modulates open to drain your tanks before any freeze damage can occur. So it's very quick acting. So how do you get your potable water tanks refilled and back in operation as quickly as possible? Well, we've actually developed a heater that acts as a cold water refill tool. So I'm going to have Glenn demonstrate how this heater works. So what it's going to do is it's going to heat up that actuator to close off the valves that you can refill your tanks without anything any water draining. So once it's plugged in, you're going to see that there are two indicator lights. The first indicator light is going to show that the power is on, and the second is going to show that the heater is working. So here you can visibly see that the heater is working and the power is on and it's functioning properly. We do offer two different heater options. We have a 120 VAC, 74 DC dual voltage heater, as well as a 230 VAC heater. These heaters are self-limiting, so you'll never overheat your actuator. So we hope that this was educational and you learned more about how our valve and heaters operate to protect your investments in your passenger cars. Thanks again for tuning in, and now back to the presentation.
Thanks very much, Glenn and Dana, for the presentation and video demonstration. And now it's time for some questions. As a reminder to our audience, if you have a question, please submit at any time via the Ask a Question box. Glenn, would you be able to talk a little bit about how the Guru PC withstands hazardous conditions?
As far as if the valve is mounted on the underside of the train, it would have to have a skid plate mounted to it. But it also has features on it where it would have to have the heater attached to it.
Okay. What about the lifespan of the valve? Can you talk about that?
Yeah, typically it's usually about a 2-year turnaround, which we have an easy reinstall rebuild program where you wouldn't have to disengage the valve body at all or any plumbing. You just take the cap out and replace all the internals. Gotcha.
In terms of retrofit, can it be retrofitted into an existing system or replace an older freeze protection solution?
Yes, it has 1 7/8 spacing and 3/4 MPT pipe connections to it, which is already on the most existing passenger trains.
Got it. Anything else that you'd like to add in terms of benefits that perhaps we didn't touch on?
Well, so the video, what that showed there, as you saw when I hit the actuator with the freeze spray, yes, you'll see the valve open up and drain out. But because we're in ambient conditions up around 70 degrees or something like that, you probably noticed that the one on the left closed almost about as fast as the one on the right that had the preferred heater attached to it. And so you have to keep in mind that's because it was at room temp. The freeze spray we're using gets about minus 45 F. So, but what happened was they both started heating up about the same time. So out in the field, if the passenger car is out of service and it's below freezing, below 32, we'll say, you have to remember that once the power is applied to the passenger train car, and these valves are typically located either between panels or inside of like maintenance box areas or the equipment areas, that you would have to wait for the ambient temperature to raise high enough for the actuator to get above 40 degrees F for it to reset, which could take upwards of like an hour or so. That's why earlier in the presentation, we had preferred in parentheses, because what will happen there is when that heater is connected to the valve, it'll actually close the valve back off once power is applied to the train within 3 to 5 minutes.
Gotcha. Well, thank you so much. And that's all the time we have. Thank you, Glenn and ThermOmegaTech. We're going to turn now to ZTR and Umerjit Zura, Senior Engineering Manager of R&D and Project Management, and Scott Stepp, Railway Internet of Things Sales Specialist. Umerjit is a 25-year rail industry veteran. With ZTR since 1999, he's led several product developments, both domestic and export. Scott, too, is a 25-year railroader. He's held leadership roles at Class 1s and short lines and at a railcar lesser. He's worked for ZTR since 2019. And as a reminder to our audience, if you've got a question, please submit anytime via the Ask a Question box. These two will be discussing the Railway Internet of Things and intelligent locomotive starting technology. Welcome, gentlemen, and thanks for being here.
Thank you, Mary Beth. Thank you, Railway Age, and thank you, audience members, for giving up your valuable time this afternoon to join us or wherever you may be in the world. I'm excited to talk to you about our product KickStart. And before I get into the details and benefits of KickStart, I'd like to outline the progression of a problem as it relates to locomotive starting and what KickStart is trying to solve. So beginning back in the early 1980s, or before the 1980s, locomotives pretty much ran 24/7, water-cooled engines. So to prevent the risk of freezing, they're running 24/7, especially through the winter. This wasn't detrimental because there was a lower cost of fuel at the time. Weren't any real regulations in place for shutdown policies. And when the engine did shut down, there weren't any taxing loads on the batteries such as computers. So the batteries lived in a nice state here, the lead acid batteries. They were being charged all the time. And once in a while, they'd discharge for restart, and then they were charged immediately. Moving into the 1980s, demands on the batteries started to grow. The fuel prices were rising at this time, which resulted in the railroads starting to enforce manual shutdown policies to conserve fuel. This, coupled with the introduction of computer and microprocessor control systems, where some functions needed to stay active when the engine was shut down, started to tax the batteries and demands on them. In the 1990s, the demands for the batteries continued to grow. Although there were improvements as it relates to the battery technologies themselves, voltage regulation and charging systems, the loads continued to grow. Legislative requirements led to technologies such as automatic engine stop systems, which the railways rapidly adopted. And there were more increased loads as it relates to, for example, driver's displays and other cab electronics when the engine was shut down. So more taxing on the batteries. Moving into the 2000s with the modernized locomotives as we know them today, everything else we just discussed. On top of that, we had computer monitoring systems such as PTC and other systems with telematic devices that need to stay connected and transmitting information when the engine is shut down. And again, not what lead acid batteries are really meant to do. So put another way, this is early battery degradation, as in the impact is locomotive starting. So the lead acid battery excels at providing the temporary power source for starting. However, today, through time, lead acid batteries are used more like a continuous power source for onboard computers and other loads. And these batteries aren't designed for continuous operation, and this ultimately leads to a decrease in the battery power availability, as depicted in this graph here. And one of the biggest problems this leads to is what's called dead won't start, a metric in the rail industry that describes an event where the locomotive failed to start due to battery-related issues. So our solution to this is KickStart. So KickStart is not a battery replacement. Rather, it is it works with the battery and assists the battery during engine cranking. It's a supercapacitor-based system, and some of the benefits of supercapacitors over lead-acid batteries is their ability to discharge quickly so they can provide the rapid power required to turn the engine in harsh environments, and also they can recharge quickly as well. So they recharge this fairly quickly and ready for the next starting event in no time. And the principle of operation is such that at the time of a crank, the system is charged up. So the batteries may or not have the capacity to provide the engine to power to turn the engine. It could be bad state of charge, bad health, sulfation on the plates. So KickStart provides that rapid power to get the engine turning and helps the battery. And then the battery comes in and away the engine turns and it gets to starting RPM. So this solution is applicable to older locomotives, modernized locomotives, basically anything with electrical starting solutions. And it improves the starting reliability, reducing the metric I mentioned earlier, dead won't starts, quite drastically. And another benefit on automatic engine start-stop AESS equipped locomotives, we're seeing a reduction in idle time because of the impact KickStart has with the batteries at the crank, and obviously environmental benefit from this as well. And we'll touch on this in the coming slides here. So we conducted a study on a handful of locomotives that are equipped with the ZTR Nexus control system. And the control system has a smart start, which is our AESS system built into the Nexus system. So what we did was we took a handful of locomotives at a period of time before KickStart was installed, and then KickStart was installed on these handful of locomotives, and that exact period of time was monitored after KickStart was installed. And we saw some qualitative improvements with the parameters shown below, and I'll dive into a little more detail on the slides here. So average crank time reduction by introducing KickStart. So typically, for those of you familiar, when you see an engine cranking, the battery voltage will typically drop, from say 64 volts down to maybe 50 volts or 40 volts. With KickStart, we're seeing that battery drop not so much. It's actually about, if say before it was 45 volts, now it's maybe 55 volts with KickStart. And because of that, that means a higher engine rotation velocity, which means it gets to running RPM quicker. So what we saw here was about a 24% reduction on average in crank time, and obviously less is better for less wear and tear on the starting equipment. Battery voltage restarts. So most AESS systems will restart the locomotive if any of a number of parameters reach a threshold where it's not satisfied. So before KickStart was installed on these locomotives, 27% of the AESS restarts were attributed to battery conditions. That number dropped down to 4% after KickStart was installed, an 85% improvement or reduction, depending how you look at it. Idle time reduction by introducing KickStart. So again, most AESS systems, I just talked about when the conditions for restarting, they have to have certain conditions to be satisfied before the engine automatically shuts down. It could be temperature, water temperature, brake pressure, a number of things. And one of them is typically battery charge. So this number here, what we did was we looked at the idle time when all the other parameters were satisfied and the AESS system is just waiting for batteries to be charged up, typically dropping below a certain amp hour charge rate. And that number reduced by 55% after KickStart was installed on the monitored locomotives. So you can see in the bottom graph there, it's maybe a little bit hard to read, but there's a blue line that shows something like 25,000 gallons where the engine is idling, just waiting for batteries to be charged up. Everything else is satisfied. And that number dropped to about 11,000 on those monitored locomotives after that. So about a 55% reduction in fuel consumption, and obviously a pretty good environmental benefit from there as well. So here's just a summary table of what we just talked about. So you can see the average crank time reduction after KickStart was installed, 24%. And then there was about an 85% reduction in the amount of AESS restarts due to battery, and about a 55% reduction in idle time where the AESS system was waiting just for the batteries to be charged up. So thank you for your time and attention. And at this moment, I'd like to turn it over to Mr. Scott Stepp.
Thank you, Mary Beth and Am. On behalf of ZTR, we thank RailwayH for providing us the opportunity to briefly discuss how we address the achievements of insights on board the North American fleet of 1.6 million railcars. Railcars have historically presented a unique challenge, but we're entering a perfect time where things were once believed to be impossible, but now are possible. So let's begin here. For those of you who don't know us, ZTR is 3+ decades of rail industry supplier with strong focus in freight rail. Historically, locomotive controls and fuel and battery management systems. We're also developing monitoring capabilities and solutions that have spilled over from another division of our company, which has equipped monitoring well over 450,000 assets. This is how we entered the railcar monitoring market. You can have a lot of customer dialogue in those 30 years. And as relating to the uniqueness of a railcar, a few key needs have come through loud and clear. The current state of understanding where's my railcar is pretty much insufficient. So honestly, I blame Domino's Pizza. You know, you can go and order a pepperoni pizza and know exactly where it is and when it's going to deliver to your doorstep, right? So in today's rail operational environment, it's nearly impossible to remotely tell whether a rail car is in motion, or it's in a location at any given moment of time. Also, the industry wastes a lot of time, effort, money, and on resources towards reaching settlements, disputes such as demurrage and usage of rail cars. So kind of back in the day when I was a fleet manager, I'll just make this long story short, but I exhausted endless hours of research and resources to search for a 4-state region for a rail car that was missing for about 8 years. And at least that's what CLM data was telling me at the time. So with no luck at finding that rail car, I eventually found myself sitting at a bar, having a conversation with a complete stranger over a beer. And needless to say, it was my lucky day. My newfound friend told me about a rail car that was sitting next to his workplace that had been sitting there for many, many years. So we all know that you cannot rely on this kind of luck. So there has to be a better way, and technology is that way. So technology is a great mechanism because it enables positive change, right? In this case, we're talking about these telematic gateways that provide GPS location, accelerometer functions, and additional sensors, which can be used in many different ways, such as monitoring conditions and health of a rail car. But to make this a little more real world, when applied to a rail car, it allows the rail stakeholder to greatly enhance the customer relationship and experience. And I'm going to kind of revert back to my little domino story. Now I know when to round up my kids and get them ready for dinner. So it makes my job a lot easier, right? If you know location with a significantly improved level of accuracy, we can address issues with delays, ETAs, misrouted cars, just to name a few. But in order to make that technology work, you need the right partner. And for that, our partner is BlackBerry. So in my opening slide, I mentioned that historically there's been a unique challenge with regards to rail cars. And specifically, that's the lack of power supply. As Am showed, we're experts in locomotives. Locomotives have a massive supply of power available, but for rail cars, that's a pretty tall order to fill. So as we invested in developing a rail car monitoring solution, we most certainly had to address the power issue, and there's a good reason why BlackBerry and ZTR partnered to develop the powerful railcar-centric monitoring solutions. So ZTR's track record and capabilities in the rail market, coupled along with BlackBerry's battery technology, power management, and edge security, and voila, Pivot was born. So that's it at a high level. So let me tell you a little bit more of what this means. So recognizing there's a lot of information on this slide, the things I want to make sure we share is that Pivot solves the power issue with the battery life. It's well over 5 years, which is important once your rail cars are released and running out in the network. And a few others to note is the security, particularly right out on the edge. So it's an absolute requirement because we're dealing with customers' data. That's your data. And BlackBerry has the long history of the best-in-class security, performance, and protocols that are baked right into the Pivot, frequently updating, and they're frequently updated through secure over-the-air transmissions. And then scalability, I'd like to touch on a little bit. It's possible to start a railcar monitoring solution journey with an easily installed GPS gateway. And then down the road, if you want to add sensors, you can do that in the future to gain added insights for taking action upon. So you've got your car equipped now. So what's that look like? So in a few words, the picture becomes much, much more clear. All right. The benefits of shared data can dramatically improve railroad operational efficiencies. Everybody wins with the telematic solutions on a non-powered rail asset. Share and untapped data throughout your business will drive efficiencies and open up opportunities for growth. We often hear this old adage in the rail industry all too often: if it ain't broken, don't fix it. Well, I got news for you. Yeah, it might work, and it's not broken, but the way we conduct business with currently tracking cars in this industry is very inadequate. There are many use cases which drive operational improvements, and more of that will come in the future. So with that said, I know there's a lot to consume here from the slides and such, but and such a short amount of time to present it. But should we come across each other at a bar, I'd hope to hear your story of implementing ZTR's Pivot Railway telematics solutions and all the success and benefits that it has provided. And with all that said, Am and I welcome your questions and follow-on discussions on how ZTR might help. And thank you again.
Thanks so much for your insight, Murjeet and Scott. As he said, it's time for some questions. And just as a reminder, if anyone does have a question for our presenter, please submit at any time via the Ask a Question box. We'll start with you, Murjeet. Can you tell us about training, and does KickStart require special training for crews?
No, not for the crews. The operation of KickStart is transparent to the crews. They don't have to do anything different. For the maintenance personnel, because they're servicing batteries and KickStart is in and around the battery circuits, there's a little bit of training, but it hasn't been a problem with training implementation for our customers.
Okay. What about installation? How many have been installed to date?
I'm going to say close to 1,000 if we haven't exceeded 1,000.
Wow. What about primary users? Can you talk a little bit about that?
Sure. It ranges from the short lines to the class ones, but the vast majority of installations as of today are with the class ones.
Gotcha. Scott, moving on to you. What about ZTR Pivot? Does it use solar power? Is that something that it uses?
So Mary Beth, no, we don't. And that's kind of why we brought BlackBerry into the pictures, because their expertise in battery management. And one of the areas that we really focused on when we were, we did want to look at all avenues of energy, because the railcar doesn't have a battery set. All you basically have is pneumatic air and some vibrations. And so solar, we looked at it as, in the rail environment, it's not optimal because of the placement on the rail cars. You're in an environment that's very dirty and gritty. These cars get visited and seen maybe once every 5 years if you're lucky. So once these things are caked with dirt and grime, they're going to be a little more inefficient. And the battery technologies for rechargeable batteries kind of really don't like to last very long in the rail environment. So that's why we decided to go with the BlackBerry solution.
Sure. What about most promising uses of additional sensoring? What do you see?
So you hear a lot of chatter out in the industry. There's a lot of movement tied around safety, number one, and I think the rail car health. So one of them that comes up very often is like handbrake sensoring to determine is the rail car moving with the handbrake on. Also, you're looking at air brake health. A lot of interesting subjects they're looking at is impacts. So we make sure the cargo's being handled correctly from point A to point B, and then identifying those areas of concerns. As we learn more and more, that data is going to speak to us, and we're going to learn better how to manage our maintenance plans, our maintenance programs. When you look at like a CLM data coming at you with mileage reports, and you compare that to actual GPS mileage of the back and forth, it's a drastic difference. And so you're probably getting more wear on your wheels and your roller bearings than you actually know that you're getting.
Anything else that either of you would like to add that perhaps you hadn't had a chance to discuss or you'd like to add in?
No, go ahead, Neil.
Go ahead, Scott.
I called you Neil. I work with Neil way too often, and I'm sorry about that. No, I just, again, we appreciate you letting us come forward and talk about our products, and our numbers and emails are displayed there. So if there's any questions after the fact, feel free to reach out to us. We're very open to doing pilots at ZTR as well. So that's something that's welcoming. So if you're not sure that this technology is you're ready for it, we can set up small, simple pilots for you as well to get you used to it and understand the usefulness of it.
Yeah, that's a great point. Well, and just to add on to what Scott's talking about with pilots, in my presentation, I outlined that we did KickStart installations and monitored on some pilot units. So with KickStart and pretty much just about any ZTR product, whether we're piloting or going for a full-blown program, we provide monitoring services as well. We can make that available so that just to reduce the burden on the customer side in terms of evaluation.
Great. And there's more information in our event resources section for the audience to look at as well. This wraps up our second Supplier Innovations virtual event. On behalf of Railway Age and Railway Track and Structures, I want to thank Glenn Quinty and everyone at ThermOmegaTech, and Umerjeet Sura and Scott Stepp and the ZTR team for joining us today. We appreciate your support. And thanks to all of you in the audience. And please join us September 29th at 2 p.m. Eastern, when Bill Wilson, Editor-in-Chief of Railway Track and Structures, will host the Maintenance of Way and Technology event. Have a great and safe day, everyone. Thank you.